Hello everyone. In this video we are going to see another problem in power electronics. The question is the three-phase modulating waveforms VA, VP, VC of t used in sinusoidal PWM in a voltage source inverter are VA of t equal to 0.8 sin omega t, VP of t equal to 0.8 sin omega t minus 2 pi by 3 volts, VC of t equal to 0.8 sin omega t plus 2 pi by 3 volts, where omega is equal to 2 pi into 40 radian per second is the fundamental frequency. The modulating waveforms are compared with the 10 kilohertz triangular carrier waveform whose magnitude varies between plus 1 and minus 1. The VSI has a DC link voltage of 600 volt and feeds a star connected motor. The per phase fundamental RMS motor voltage in volts is closest to option A 424.26, B option B 300, option C 169.71 and option D 212.13. This is a multiple choice question. We need to calculate the answer and tick the correct option. The solution of the given problem is given here. We know that for a three-phase inverter, the expression, phase voltage expression is given by this formula, which is VAN equal to MA VDC by 2 sin omega t plus harmonic terms, and the line voltage expression is equal to root 3 MA VDC by 2 sin omega t plus pi by 6 plus higher frequency sidebands. Here MA is the modulation index, which is the ratio of the amplitude of the modulating signal to the amplitude of the carrier signal, and VDC is the DC link voltage, and these are all the harmonics. In our question, we are asked to find out the phase voltage, RMS value of the phase voltage. So in the given phase voltage expression, this is nothing but the peak value of the fundamental component. In our question, we are asked to find out the RMS value of the peak, RMS value of the fundamental component. So this is the peak value of the fundamental component. If we divide this by root 2, then we will get the RMS value of the fundamental component of the phase voltage. So considering this expression, we need to find out the modulation index and then amplitude modulation index MA, and then the VDC is given. So modulation index is nothing but AM by AC. AM is given as 0.8 and AC is given as 1. So MA will be 0.8. And the VDC in the given problem, DC link voltage, it is given as 600 volt, which is nothing but the input voltage of the voltage source inverter. So we can find the phase RMS, that is peak value of the phase voltage fundamental component as MA VDC by 2. If we substitute MA and VDC values, then we will get the peak value as 239.99 volts. This is the peak value of the fundamental phase voltage. And to find the RMS value, we need to divide this peak voltage by root 2. So dividing that, we will get 169.698 volts. So in the given option, the option which is closest to the obtained answer will be the option C. So option C is the correct option.